Hello students, so we will be solving one problem based on molar conductivity and its relation with the concentration of the electrolyte. So refer to page number 80 of NCERT book of page number of part 1 class 12. We are doing this numerical from the chapter 3 electrochemistry. The problem statement is number 3.6 in page number 80. The molar conductivity of KCl at 298 Kelvin in different concentration is given. It is given in the form of a table. The table is like this. One side the molar concentration is given and molar concentration is given in terms of mole per liter, and other side the molar conductivity is given in terms of Siemens meter square per mole. So there are four values which are given. These are 0.000198 and the unit is written at the top, 0.000309, unit is mole per liter again, 0.000521, unit is given again mole per liter, and 0.000989, unit is mole per liter for all. So for each of these corresponding value, the molar conductivity is given. Molar conductivity for this concentration, the first one is 148.61. Molar concentration for this is 148, very close value, 0.28, that's 29, and next is 147.81 and 147.09. So now we have to find out the relation between the concentration. Means the question is show that a plot between lambda n. So this value is what? Molar conductivity. Molar conductivity is given in terms of lambda n. So we have been asked to show that the plot between square root of concentration and molar conductivity is a straight line, because we know that molar conductivity is equal to molar conductivity at infinite dilution minus A is the constant which depends upon the nature of electrolyte multiplied by root C. So actually they are trying to ask that whether the given data obeys this equation or not. Okay, so this is what they are trying to ask. Now the value of C is given to us. These all are value of C concentration. So we have to find out the value of root C for this. So we can apply mathematical tricks. Someone can use log table, logarithmic value, or someone can do some short approximations also. Alright. So whichever method is easy for you, you can follow, and the value of root C is found out. I can do little bit of rough calculation to show how the value of root this can be found out. Say if I have to find out the value of root 0.00198. So if this value I have to find out, then what I will do is I will find out like this. I will take, let x is equal to, b is equal to square root of 0.0000198. So log x will be equal to log 0.000198 to the power 1 by 2, because this is nothing but 0.000198 to the power 1 by 2. So we can find out log x will be equal to half will come this side, and the value of log this can be again further written as 1.98 into 10 to the power 4 minus 4. So this will become 1 by 2 log 1.98, and this will become plus log 10 to the power minus 4. This will become 1 by 2 log 1.98 minus 4 log 10. Value of log 10 will become 1. So this will become 1 by 2 value of log 1.98 we can find out from the log table. We can use log table which is there in the end of this textbook. So in this log table for 1.98 we will see 19s under 8, 19, and under the column of 8 it's 296. We will write 0.2967 minus 4, and log 10 will become 1. So it will become half, and 4 minus this much we have to find out, minus 3.7033 divided by 2. You can divide it by 2 again. So this comes out to be minus 1.85165, but this value cannot be negative if we want to find out the anti-log of this. So this was all value of log x, log x, log x. So we have to find out now x. So x will become anti-log minus 1.85165. So we can take it as 7, but this negative has to be converted into positive. So what we will do, we will take it like this: anti-log al minus 2 will write as 2 bar point plus 2 minus 1.8517. So this will be 1 bar point 14835. Now we will see the value of anti-log this much. Anti-log 0.1483. So again we turn the page, and in the anti-log table we will see the value of 0.1484. So 0.14 under 8, this will become 10 to the power minus 1 anyways, and this value is 407. 10 to the power minus 1, 10 to the power minus 1. If you know the rules of logarithm, then this 1 bar is written as 10 to the power minus 1, and hence this value is 0.01407. So we can, instead of this, we can write now here square root of c will be 0.01407. Likewise, we can find out the value of root c of all these three values, which comes out to be 0.01758. Value of root c for this, and 0.03145. Now this is a universal method of finding out the square root of any number which is not a perfect square. This is a universal method, but some of you may use a trick also here. A small trick can also be used to find out these values. Okay. One small trick can also be used. This is a long method of calculation which can kill your time in the exam. So short method would be, we can do some rough approximation of this. Like each of this value I can write as 1.98 into 10 to the power minus 4 is approximately equal to 10 to the power minus 4. Similarly, this value will become 3.09 10 to the power minus 4, approximately equal to 3 into 10 to the power minus 4. Similarly, this is 5.21 10 to the power minus 4, approximately equal to 5 into 10 to the power minus 4, and 0.0, this becomes 9.89 10 to the power minus 4, approximately equal to 10 to the power minus 4, and root of all these, if you have to find out root of all these, so this will become root of 2 into root of 10 to the power minus 4 will be 1.414 10 to the power minus 2, and root of 3 10 to the power minus 4 will become 1.732 10 to the power minus 2. Root of 5 will be somewhere around 2.2 10 to the power minus 2, and root of 10 10 to the power minus 4 will be somewhere around 3.1 10 to the power minus 2. So these approximate value can also be found out, and if there will be any deviation after decimal point in the answer, marks will not be deducted, but there should not be hell and even difference in the answer. So these are the two ways. All the methods are very simple, but where you can get caught is converting this complex value of c into root c. Alright, so I have told you two methods. One is by logarithmic method, you can find out c, or you can find out by some approximation. So there are these two ways. Now after you do this rough calculation or fast calculation, whichever method is easy for you, this is going to be difficult, but it is universal. This can be applied anywhere. There can be some numbers where approximate value will be much away from the original value. So this is like, universal method, and this is a trick method. Alright, this is faster method, this is a longer method, it is a universal method, can be applicable everywhere. This can be applicable for such numbers which are close to some integral values. Okay, so I have told you both the tricky methods of finding out this value. Now I can erase it for my convenience. You can pause and you can take down. So that is the charm of the video lecture. Unlike classroom, once erased, you cannot review blackboard work. But once video is captured, you can always pause and review. So it's a very good method. Alright. Now we have reached halfway. Now we have what we have to do. We have to plot a curve between root C and molar conductivity. Alright. So we'll draw one graph. I wish I had a digital board in which I could have just brought one ready-made graph and then I would have put the value. But since I am doing it manually, so it will be like this itself. Now, at the x-axis, we will keep the value of root C, and at the y-axis, we will keep the value of molar conductivity. Now we have to set some suitable scale. So what could be the suitable scale? Here, if I start from 0.005, then I will get 0.01, then I will 0.15, 0.25, 0.30, and 035. On the y-axis, we can take 147. Which one is the smallest one? Smallest one is this one. So we can start from here. Say this is 147, and say if I take 148, 148.61. So 148.61 will be somewhere here. Corresponding to this value, 1.014 would be somewhere here. So this is one point. This point is for 148.61, 0.014. Similarly, for this is done. Next is 148.29. 148.29 would be somewhere here, and corresponding to that 1.17. So 17 would be somewhere here. So you can draw it like this. So this will become 148.29 and 0.1758 approximately. I am doing it roughly, and you can use a graph paper. For you, use a graph paper and do it properly. Then next is 147.8. 147.8. Yes, very much this value. And 0.22 would be somewhere here. So this value comes out to be 147.81 and 0.02283. Again 0.030 this value and 147.09. 147.09 will be more than this, somewhere here. So if I join these points, since I am doing it without scales, I have manipulated it a lot. I have done lots of manipulation. So if I first of all draw this line, and if I extraplot, then this will go and touch somewhere at 150. All right. And this will touch somewhere here. Now in your graph paper, whatever value you will get, if you find out the difference, say this is 147.09 versus 0.03145. In your graph paper, if you will do it properly, then the end values of the coordinates, whatever will be there, if you find the slope of that, all right, slope is always perpendicular by base. delta perpendicular by delta. So we can find out the difference in the coordinates of this. So after extra plotting we are getting it at 150. So we can take 150 here minus, and if we go downward, then this value what we will get will be, I have done it in a graph paper, from there I am seeing 147.5 and divided by this side, we can take initial value to be, this will be 0.0345 and minus initial value 0.005. This value comes out to be 2.5 divided by 0.0295. So this will be equal to around 84.75. Now, depending upon the scale which you will choose and the coordinates which you will choose to find out this slope, this value may differ a little bit. So for this also marks won't be cut. Marks won't be cut for little bit of deviation in this value. This value what we have got is slope, and slope is nothing but a. In the equation, lambda m is equal to lambda m at infinite dilution minus a root c. Value of lambda m varies with concentration, but lambda m at infinite dilution means when concentration is 0 at that time. Alright, so lambda m when infinite dilution takes place and concentration is 0, so this is equal to 150, and value of a corresponding to this is equal to 84.75. So with the help of this straight line or slope, we can find out the value of a, which is given in the question also. In the question also it is asked that show that lambda m, show that the plot between square root of concentration and molar conductivity is a straight line. So we have shown first. Second is also there. Determine the value of, second also question is there now. Determine the value of molar conductivity at infinite dilution. Molar conductivity at infinite dilution when concentration is 0. This has been done by extra plotting the curve, and value of a. So value of a will be the slope. Value of a will be the slope, this slope, and slope is found out by finding the ratio of the change in the values of the coordinates. Alright, so this difference divided by this difference in the perpendicular divided by difference in the base, alright, gives the value of slope. So we have found out this also. Now if marks will have to be given, this will be a 5 marks question. How? For drawing this curve, you will be given 2 marks. For getting these values, you will be given half marks. What I will do is I will use red pen for this. So you will get 2 marks for proper drawing of the graph, half marks for this value, half marks for this value, and for getting these values you will get half marks each. So it comes out to be 2, 3, and half marks for this, half marks for this, half marks for this, and half marks for this. In this way, examiner divide the value points in an answer. So even if you approximate somewhere, the examiner does not have any option other than giving you half marks, because it is a very low weightage value point. So even if you get somewhere approximate answer also, at approximate value, you will get half marks in each of these. And say if you get here 83.9 due to some reason, like if the resolution of the graph or the scaling has not been done very much accurately, so this value can differ. So if this value differs by a few decimal points, then marks won't be deducted. Alright. So for drawing proper graph, you will get 2 marks. For this rough calculation, you will get 2 marks, half mark each, and half mark for finding out the lambda m at extra, lambda m, or molar concentration at infinite dilution at half marks, and for finding out A, which is a constant in this equation, half marks. So in this way, this will be a 5 marks question, which requires lots of practice. So use a graph paper and practice it once. Alright. You will find that it will become easy for you then. Thank you.